the toughest problem first. So we're going backwards. So my going backwards is from the top down instead of the bottom up, right? Approach. We're so used to the building on the foundation, bottom up approach. So we're starting tonight. How many are going into the engineering field, right? Awesome. So most of you that plan to become engineers, you're probably familiar with reverse engineering, right? You see your competitor's product, you want to take it apart, and then see what they did, and then see if you can make it cheaper, make it faster, make it more durable, and bring it to market much quicker, right?
Fuel efficient.
Yes, efficient, be very efficient. So that's called the top down. And what I found is, I noticed the students will really understand the concept. The first 20 minutes, if we go through the toughest first, they'll retain it in their brain much more readily. So our exercise tonight as we review is to ask other students who came here earlier and we discussed it with them to share how they would go about solving a problem like this. So, Latoya, you get to be the first one, number 18, next percent. So you want to go up to the board. And then Flash will be the next one, and Claudia, you'll top it off with number 20. So let's give
No, please.
Okay. So feel free to ask her questions, right?
No.
Okay.
I didn't plan on
I'm
having
sorry.
to explain this. So number 18 just gives you this C9H804, and it wants to know the percent of each element here. So the first thing you want to do is you want to find out the atomic mass of each individual element, and then it tells you how many there are. So you'll take that number times the atomic mass, and it'll give you the total amount of that element in the compound. So for carbon, when you take 9 times its atomic mass, you find that there's 108.09 grams. And you do the same thing for all three. And of course, when you find a percent, you have to have a denominator. So in order to find out how much of each one of these as a percent is in here, you want to add all of these together, which gives you a total of 180.15. And from there, you can calculate the percent of each one. It's just the amount of carbon over the total number in the entire compound times 100, you get 60%. You know, everything has to add up to 100, so that's kind of your check at the end to make sure that everything totaled out correctly.
That's pretty cool, right?
Yes.
Yeah. Thank you. Okay, so France, next. Actually, you can also, for those that brought your textbook, turn to the page that has example 3.15. We'll let France get his things together in the corner. Take a look at the problem on 3.15, using mass percent as conversion factor.
That's what page?
What page is 3.15? You can either use the...
Never mind.
You found it, awesome. What page is it?
105.
Okay, so page 105 for those that have the second edition, and for those that have the third, what page is it? So take a look at that problem where the Food and Drug Administration recommends a person to consume 2.4 grams of sodium per day. What mass of sodium chloride can you consume and still be within the guidelines of sodium to be 39% sodium by mass? So you always first write down what you're given, as we learned in chapter 1. Write down what you're given, and then go ahead and find out what the grams of sodium chloride you need. So even though, you know, the sentence is really pretty long, right? Lots of highfalutin words. you want to key in on what mass of sodium chloride can you consume and still maintain the FDA guidelines. And so, therefore, you set up, you write down what you're given, 2.4 grams of sodium, and because it's percent, so you assume you had 100 grams, right? And since you want to cancel grams of sodium, so therefore, you want to write down, instead of writing 39 grams of sodium per 100 grams of sodium chloride, you want to write down the conversion factor to be 100 grams sodium chloride over 39 grams of sodium to cancel out grams sodium, and you end up with 6.2 grams sodium chloride. Okay? So, are we ready, friends? Okay, awesome. Let's give the floor to friends.
But as we see, the compound we are going to reduce. We have 10.4% carbon. Okay, they ask you what is the empirical formula for this compound. If you have 10 point, you take this one, you put it on a gram. I think you put it on a gram, and then you know the carbon, the mass carbon is 12.011, and then you want to cancel this gram, and then you end up with the mole. When you cancel those, and then you divide it 10.4 by 12, it's gonna give you the answer right there for the carbon. This is the more carbon. You do the same thing for 27.8, and then for chloride you do same thing for those two.
Any questions there? Awesome, friends, thank you. So the answer? So if you look at 3.1 in your textbook also, right, as Claudia gets ready to set up, look at 3.1. What page is that, in the third edition or in the second edition? So in the board here, determine the empirical formulas for C4H8, 3286, CCl4. So we'll let Claudia explain if we're doing some elemental analysis, right? And it's hard to read that. And let's see if we can turn the little Elmo on and put the problem as you explain. Can you write the, can you make it darker and write,
I can do this one.
yeah, see if that will write, so, right.
Okay, so basically at number 20, we need to find the molecular formula of the hydrocarbon. So to do that, we first find the formula weight of the CH2 that this would be the empirical formula. So the C mass is the 12.011, that's in the periodic table. You add that to the two hydrogens, and this is how much the weight is. Comes out to be 14.027 grams per mole. Then they tell you that
Chlorines, there's 2, and
Barium?
barium is 1. Sulfur is 2.
Sodium.
Yeah, sodium is 2, and oxygen is 4. And then I balance those because since it has to be balanced, because matter can't be created nor destroyed, everything's the same. But here I had to multiply by 2 to get 2 sodium and chlorine.
Sodium chloride, okay, in solution. And that's pretty nice. She even put the type of reaction, double displacement. Why? Because barium, right, reacted with a sulfate to get a solid barium sulfate, while sodium reacted with chloride to make a sodium chloride liquid aqueous solution. Really nice, thank you. Awesome. Okay, the teacher here.
So I did the same thing as everyone else. Mine was just a little bit more math involved, I guess.
Share with us what
So-
grade you teach.
Middle school, 6th, 7th, 8th. I'm like their full-time sub, so
Oh, we're right there.
That's really, really cool, isn't it? Yeah.
sometimes.
Yeah, because they can have some really awesome ideas.
Yeah, they do. They help me with my homework. But yeah.
Okay. Okay, I think we have another gentleman whose was this up here? Did someone write this down? Oh, you did? Oh, okay. Anyone else? Oh, you said you were gonna write something, right? Sayed? Oh, yeah, go ahead, yeah. Sayed has, so let's go ahead and put it here. So now you have some idea on how to balance reactions, so yeah. Right, big, can you talk while you write? He'll try, right? Sometimes. Press down, right? So what letter are you doing?
I'm doing B.
Okay, letter B, where we have zinc solid. And okay, who's going to do it? Daniela? Veronica? So he checks out the thing, you have two extra. So any other questions you may want to find out before the exam? Give me send me an email. How many of you have heard of Socrative, where I will ask the question and you see your iPhone. You answer, and then we can see how many students know a particular question. We'll try to work on that. I forgot my iPad. I have it set up in my iPad. My little iPhone is like the other student, so we'll try to do that. How many of you do you think can do that? Or we'll try to divide the class into groups, right? There's also some activities I want to try. In Socrative, when I divide into groups, it's called like a space group, so different colored spaceships.
That would be fun.
So that would be fun, right?
Yeah.
And then you'll get a group grade for that.
It works on Android and iPhone.
Yeah, iPhone or Android. Yeah. It's called Socrative. So actually, for those that can do it now,
I think it's anybody that has text messaging, right? Because
Yeah.
you text it, so.
yeah, and then I'll tell you my classroom number, and then you just type down the room number, and then I'll just say a question, and then you choose A, B, C, or D. Yeah. Really cool. Okay, so let's give the floor to
Yeah, I want to
Sayed.
explain this way. Actually, I balanced out the biggest number first, which is NO. I took this part and this part to balance it out, make it equal, and make this one equal, I found that I gotta, you know, yeah, I gotta increase 3 genes, so I have only 1 gene on this part, this side. So I just, I mean, you know, but add 3 on this side, then I have 2 iron, which is FE. I gotta increase 2 iron this side and to balance out this one to make it equal. Actually, my whole point is here, which is NO. I balance out NO, then I have to do add 3 on zinc and 2 on iron, and this side 2 on iron, 3 on zinc.
Okay, any questions there? Pretty cool, huh? Nice and easy and simple, awesome. Good job. Okay, so I believe we can balance equations, write down the coefficients to balance the equation fairly well. Yes, Reed?
So on the tests, are we gonna have to know whether they're a combination, decomposition, single displacement?
No, because not yet.
No,
Yes, we covered that in
So not
chapter
to worry
4.
about that.
Right. But you know, some students are a little bit ahead, so I want to keep their interest going. Good point, very good point. Any other questions in the review? Yes, Amanda?
Do you have a room number set up for competition or no?
Yes, I do.
Can you tell us it?
Okay, sure. Or, it's in my iPad, my iPhone is my student number. So I play the teacher and the student. Oh, so another thing, right? What do you do when your brain is really tight and seems like, but then you get tempted to eat all the really bad junk food, right? What should you be eating? Or even taking before or munching? You know what I try to do? 5 or 6 almonds, right? It keeps me from getting, my brain is fried.